Hello, welcome to Pre-Cal Lecture 5.1. You will need your 5.1 note sheet handy, and you can see that we're going to be drawing quite a few graphs on this page, so leave yourself some space for that. And you will also want to have a printout of the unit circle handy, as we'll start to go over that about halfway through the lecture. So going through the notes here, on the right side at near the top of the page, let's go ahead and draw a coordinate plane, all right, in that space. So we divide the coordinate plane. This is the positive x-axis, the negative x-axis, the positive y-axis, the negative y-axis. We divide the coordinate plane into 4 quadrants. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So this is 0 degrees. Up at the top is 90 degrees. I'm going to move this a little bit out of the way. 180 degrees, 270 degrees at the bottom, and then when you get back around, just think of this as a circle going around. You get back around to the beginning, you're at 360 degrees. All right, so positive angles are measured from the positive side of the x-axis, so they're always measured from this x-axis. Positive angles sweep counterclockwise, so we're sweeping counterclockwise this way, positive angles. Negative angles sweep clockwise, all right? So if we were to go this way to about right there, that'd be like a negative 45 degree angle. If we go this way to about right there, that'd be a positive 45 degree angle. All right, so you don't have to draw that. That's just for illustrative purposes. All right. Acute angles are between 0 and 90 degrees. You might remember that from geometry. Obtuse angles between 90 and 180 degrees. A 90 degree angle is called a right angle, and a 180 degree angle is a straight angle. Okay, so we are at the coterminal angles part, so we're going to draw in there. So I'll go ahead and erase this coordinate plane. So in that space under coterminal angles, we'll draw another coordinate plane. And the positive x-axis we're going to call the initial side. And then let's draw what we'll call, so this is the initial side. It's where we start measuring from, and this is the terminal side. Okay, that's where we stop measuring the angle. So that angle, and we usually use to signify an angle the Greek symbol theta. So that angle is about 60 degrees. Okay, but if we were to, so we measure from here to from the initial side to the terminal side, that's about 60 degrees, but we could also go all the way around, all right, all the way around that circle and land on it again, and that would add 360 degrees to it. So 420 degrees looks exactly the same as 60 degrees. It's just a one more rotation. And let's say we were to start here at the initial side and go around and stop right there. The terminal side would still be the same. That would be a negative 300 degrees. All right, if we were to go around like that and then stop right there, that's a clockwise angle, so that would be negative 300. So 60, 420, negative 300, they're all what we call coterminal. right? They have the same initial and terminal side, but differing amounts of rotation. All right, so pause the video if you need to, and we'll keep moving on down the notes. All right, our first example is in which quadrant does 133 degrees lie? Okay, so you don't necessarily have to draw this out. If it helps, go ahead and do that. But we know this is 0, 90, 180, 270, right? So 133 would be 90 plus a little more, right? So 90 plus another 43 degrees. So it'd be something like this angle right here. Okay, so it resides in quadrant 2. If you don't like Roman numerals, just use regular numbers, you know, quadrant 2. Usually with the unit circle, we use Roman numerals. Okay, the next example is what quadrant does negative 1100 reside? Okay, let me draw another coordinate plane. So again, 0, 90, 180, 270, and then back around to 360. Negative 1100. Okay, we're just going to start here at the positive x-axis. That's where we always start. And go around. Okay, so negative 90, negative 180, negative 270, negative 360. We're going to go around another negative 360, so it'd be negative 720. Let's go around again. Another 360, and of course we're going in the negative direction. So the third time around we're at negative 1080, and then 20 more degrees would be negative 1100. Right, so we went around 1, 2, 3 times, and then another 20 degrees. So it terminates in quadrant 4. Okay, so pause if you need to. We'll move on. Okay, at the bottom of page 1 of your notes, finding coterminal angles and measures of coterminal angles differ by a multiple of 360 degrees. So it's pretty easy to determine if something's coterminal or not. So our next example is we want to know, is negative 570 and 150 degrees, are those two angles coterminal? Well, here's what you do. You take the first angle, subtract the second angle. That gives you negative 720. What you want to know, is this a multiple of 360? Okay, it can be negative or positive. Well, if we divide that number by 360, we get a negative 2. So it does go in a integer amount of times. Okay, there's no decimal with that number. I don't care about the negative. So the answer is yes. All right, the next example, negative 800 and negative 80. Are they coterminal? We'll take the first one, negative 800, subtract out the second angle, so minus negative. Well, that's going to give you negative 720. They would also then land in the same spot. If we divide by 360, we get an integer number. That's not always going to be negative 2, okay? Just happened that it did. But we got an integer number there. So they are indeed coterminal. If you try something else, if we tried 570 and 180, all right, and we subtracted those, okay, that would not be evenly divisible by 360. So the answer would be no. Okay. All right, 5.1.3 is finding the complement and supplement of an angle. Two positive angles are complementary if their measures add up to 90. They're supplementary if their measures add up to 180. All right, so this section is just really not very hard at all. Our first example is, what's the complementary angle of 62? Well, complementary angles have to add up to 90, so we would do 62 plus x is equal to 90. So x is going to be 90 minus 62, so that's 28 degrees. Okay, the next example, what's the supplementary angle of 90? Well, supplementary angles add up to 180. So 90 plus x has to equal 180. You can probably do the math in your head there. X is going to be 90 degrees. Okay, the next example, probably be one more like I would ask you on a test. I probably wouldn't ask you anything quite that simple. It says, two angles measuring 2x and 4x plus 6 are supplementary. What are the measures of the angles? Two angles measuring 2x and 4x plus 6 supplementary. So we're right in the middle of the second page of notes. All right, if they're supplementary, they must add up to 180. So we're going to solve for x here. So I'd have 6x plus 6 is equal to 180. 6x is equal to 174. X is equal to 29. That is not the measure of the angle. That's just the value for x. So angle 1, okay, this angle would be 2 times 29, which is 58 degrees. And then angle 2 would be 4 times 29 plus 6, which is 122 degrees. All right, you can check those. What do they have to add up to? 180. All right, and they do. Okay, so 4 times 29 plus 6. That's where angle 2 is coming from. All right, that's probably going to be something like that. Would be more like what you'd be asked on a test. I might ask, you do have to know what does complementary and what does supplementary mean. All right, let's go on to the next subject. Next section. Subject still pre-cal. All right, converting between degrees and radians. So mathematicians prefer measuring angle in radians because this measure is able to give an exact number in terms of pi. In radian measure, there are 2 pi radians in one complete circle. All right, so what we have, so you need to print this off, is the unit circle. So we talked at the beginning of this lecture about going around a coordinate plane with 0, 90, 180, 270, 360 degrees. One revolution around a circle is 2 pi radians. Okay, it has to do with the circumference of a circle is 2 pi times the radius r. Circumference is 2 pi r. And in our unit circle, the radius, this distance from here to here, is 1. All right, so mathematicians prefer to measure angle not in degrees, but in radians. So instead of 90 degrees, this would be pi over 2, pi radians, 3 pi over 2, and then back to 2 pi radians. All right, so to convert between degrees and radians, all right, so convert radians, which we will RAD, that's how we're going to abbreviate that, 2 degrees, we multiply by 180 over pi. All right, this is in your notes. All right, and then convert degrees to radians. We're going to multiply by the reciprocal, pi over 180. All right, so I'm just going to draw out in your space, in your notes, let's draw out a coordinate plane. I know you have it on the unit circle, but we need to get used to this. you need to think in terms of radians instead of degrees. So at the positive x-axis, 0 and 2 pi radians. Pi over 2 is straight north. Pi radians would be west. South is 3 pi over 2 radians. And then back to 2 pi. So you've got to, and then of course this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We need to think in these terms. Okay, so our first example is convert 180 degrees to radians. Well, you would take 180 to convert degrees to radians, multiply by pi over 180, and that's going to give you pi radians. All right, and we can even, that's one of the famous angles on the unit circle, we can even check that. 180 degrees is pi radians. All right, turn your notes to the next page. It says convert 3 pi radians to degrees. So to convert radians to degrees, we would take 3 pi and multiply by 180 over pi. The pi's will cancel, and that's going to be 540 degrees. All right, so 540 is not on the unit circle. This is actually 2 pi radians one time around, and then we add another pi to get to 3 pi. So we're at the coterminal angle with 180, which is 540 degrees. All right, and then the final section in lecture 5.1 is called the arc length formula. All right, so pause the video if you need to, and we are on page 3 of your notes. So for the arc length formula, arc length, we use the letter S, and then times R. S is equal to R times theta, where R is the radius. Theta, of course, is the angle, but you have to put it in radians. So if it's in degrees, you have to convert to radians. Okay, so when I'm talking about arc length, okay, let's say we have this circle, and we want, and here is angle theta right there. Let me draw this a little bigger. Sorry about that. There's no reason to draw it small. Okay, we've got a circle. Here's the center of the circle. Let's say we've got this angle theta right here, and we want to find the arc length subtended. Okay, the word used is subtended by angle theta. All right, let's see if I can find a different color that works. So the arc length is, what we're talking about is this distance. All right, the length of this part of the circle, right, from there to there. Okay, so that is what in blue is what we would call the arc length. Okay, so our first example about arc length says, what is the arc length of a clock between 2 and 3 o'clock if the radius is 3.9 feet and the central angle between the 2 and the 3 is 30 degrees? All right, so let's draw a clock, and we don't need to put all the numbers, but let's say here's 12, 1, 2, 3. That's probably enough. Here's the center of the clock, and what they're telling us is that the angle between the 2 and the 3 there, that angle is 30 degrees. Okay, so we want to know the arc length between the 2 and the 3. So what is the circle right there? Okay, I don't know if you can see that blue very well. Let's see if I can find a different color. Here's red. All right, we want to know, okay, that distance right there between the 2 and the 3. They told us that the radius of the clock, pretty big clock, is 3.9 feet. Okay, so S is equal to r theta. Theta has to be in radians. All right, so theta is we're going to take that 30 degrees and multiply by pi over 180. So 30 over 180 would reduce to 1/6, so that's going to be pi over 6 radians. All right, so our arc length is going to be the radius, 3.9, times theta in radians, pi over 6. All right, you can use the pi key on your calculator. That is 2.04 feet. All right. So there is, of course, another way to find theta. Let's call this the alternate way. That I think might even be easier. What portion or fraction between the 2 and 3 is that of the entire clock? Well, a clock you can divide into 12, so between the 2 and 3 would be 1/12. We know that the entire circle is 2 pi radians. So that is pi over 6 radians. That's an alternate way to think about it. What proportion of the circle does the arc length subtend? Okay, so that's another way to find the theta in radians. All right, let's do one more, and then that'll finish up the lecture. So it says, an arc of 3/8 of the circumference of a circle subtends what central angle in radians? Okay, so if you want to think of, here's the center of the circle. 3/8 would be, I don't know, a quarter is straight up, so 3/8 is going to be something like that. All right, so what angle is that? Well, the entire circle if you start here and go all the way around, is 2 pi. So we're talking about 3/8 of that. 3/8 of 2 pi is going to be 6 pi over 8. And that would reduce to 3 pi over 4 radians. All right, and then of course you could use that if you were given the radius to find the arc length. All right, that does it. The homework is worksheet 5.1, and I will talk to you next video.